All right, we're doing day 3 on matrices. We are learning about determinants, which we'll define in a minute, and how to use an augmented matrix to solve systems of equations. We have actually done augmented matrices already. We did them in September at the end of Module 2. When we had a system of equations that had x, y, and z, we put them in our calculator. So we're going to start with that. Go ahead and turn the page. Just kidding, wrong packet. Okay, given the following systems of equations, write an augmented matrix for each system. First, we should probably define what an augmented matrix is. Then use the augmented matrix to solve the system. The augmented matrix is a matrix that is formed by combining coefficient and constant matrices. That's some terrible handwriting. That's okay. Matrix that is formed by combining coefficient and constant matrices. All right, since we also have the final coming up after this, I'm first going to solve system A using like our regular system of equation methods. System A is set up pretty well for elimination, so that's what we're going to do. Here it is. If I multiply this whole equation by -2, then I rewrite it because now I have kind of a new system. You don't have to write this part down. Now when I add these equations together, I have 2x and -2x that they cancel. So that's why I multiplied by -2, was to make it so that these two would cancel. And then 3 plus -14 is -11y, and 4 plus 40 is 44. This is a one-step equation, so we divide by -11, y equals -4. To find the x coordinate, because our system always has two answers, an x and a y, we plug this into either of our two original equations. So 2x plus 3y equals 4. And we already found that y was -4. So 2x minus 12 equals 4. Add the 12 over. 2x equals 16. And then x equals 8. So our solution is the point 8, -4. That's the solution to the system. Now we're going to find this using matrices. In order to find this using matrices, both of these equations have to be in kind of a modified standard form. So you might want to write this part down. Both equations must be in ax plus by equals c form. All right, this is already an ax plus by, whoa, equals c form. Sometimes they're not and we have to change it. But because it is, we can take our coefficients, the x and y, and kind of make that a matrix. And then we have our constants, what it equals. We just do a little vertical line, and we line those up as well. That is not a 20. Okay. So then this is our augmented matrix. What we do in our calculator to solve this, so that we don't have to use elimination, is we want reduced row echelon form, RREF. So let's pull out our calculators and let's put in this matrix. Second matrix, edit. Matrix A. What are the dimensions of this matrix? Two rows, 3 columns, so it's a 2 by 3. All right, do you have the matrix in your calculator? Cool. We're going to quit. Second quit. Now when we go back to our matrix, we want to do matrix mathematics, so we go over here to math. We want reduced row echelon form, so we scroll down until we see this. It is option B. Be careful that you don't hit option A. And what do we want reduced row echelon form of? Of matrix A. So matrix, the name A. So now we have our matrix in reduced row echelon form. That means that our coefficient matrix is what we call the identity matrix, 1, 0, 0, 1. And then the augmented part is 8 and negative 4. If you remember from how we set up our matrix, what did this first column represent? X's. And the second column, Y. And then the third column were like our answers, what it equals. So here you have 1x equals 8. And 1y equals negative 4. Okay, so x equals 8, y equals negative 4. Or in other words, our solution is 8, negative 4. Okay. Pause a second. All right. System equation letter B. Both equations must be in ax plus by equals c form. The first equation is. The second equation only sort of is. I don't see an x anywhere. We cannot leave an element of the matrix blank. It has to have a number in it. So what number would we put there? 0. So this is like a 0x plus 3y equals 0. So our matrix is going to be 5, negative 8, 0. 0, 3, 0. Now we want reduced row echelon form. So I'm going to follow these steps and see if they work. Second matrix, left arrow key over to edit, hit enter. We need to fill in the dimensions, which are 2 by 3. Those didn't change. And now fill in the matrix. 5, enter, -8, enter, 0. If you hit enter in between, it's a lot easier than using the arrow keys. Okay. Now that we have the matrix filled in, second quit. Now second matrix, we're going over to math. Oh, I guess we don't need to hit enter. Just kidding. We scroll down to option B, our REF, and then we hit enter. Now we want reduced row echelon form of matrix A, so we go back second matrix. Name should be highlighted. We want matrix A, so enter, and then enter again. Here's our reduced row echelon form. So we have our identity matrix 1, 0, 0, 1, and then our answer 0, 0. Does this mean no solution? It does not. This does have a solution. Remember, our first column is is X. Wow. Our first column is X. Our second column is Y. So we have X equals 0 and Y equals 0. So if X equals 0 and Y equals 0, that is a solution. It's the solution 0, 0. So if we think about these as lines that intersect somewhere, they would intersect at the origin at 0, 0. All right. Problem C. We're actually going to change problem C. So we're going to change problem C. It's going to be negative 2y equals 3x plus 7 and 9x plus 6y equals 12. Is this in ax plus by equals c form? Are both equations? No, the second one is. The first one is not. What's in the wrong spot on our first equation? The y is first, and the x is on the wrong side of the equals sign. So we need to move this over. How do we do that? Subtraction. We're going to subtract the 3x. So when we subtract 3x from both sides, we have negative 3x minus 2y equals 7. Now this is in ax plus by equals c form. The second one was already. So we're ready to make our matrix. We have negative 3, negative 2, 7, and then 9, 6, 12. We're going to want reduced row echelon form. So we need to put in this matrix. Negative 3, negative 2, 7, 9, 6, 12. Quit matrix math. Go down to our REF of matrix A. Okay. So usually we have our identity matrix 1, 0, 0, 1, and then our answers. This is not our identity matrix. This is 1.6 repeating, 0, 0, and then 0, 1. The fact that this is not an identity matrix, 1, 0, 0, 1, means it is either no solution or infinitely many solutions. Because we have 0, 0, 1, we're saying 0 equals 1, which it does not. So this is no solution. This is a lot of work just to determine that it has no solution. Like putting it in the right format, doing all the calculator stuff to get it into reduced row echelon form just to find out it has no solution. When it has a solution, it's like less work because we don't have to do elimination or substitution, which would take a while. So it's quicker when we actually have a solution, but when we have no solution, it takes a little bit longer. But we don't really know that it has no solution until we try it, so it's like we're wasting effort almost. That is actually what the determinant is for. It's a quick process to find out if you have a solution. So we're going to do this last problem, and then before the word problems, we're going to go back to determinant. So last problem, x equals 2y minus 11, 2y equals 5x plus 23. This is not in ax plus by equals c form. Our left side needs to have x and y. On the top equation, it only has x, so we need the y to move over. So we're going to have to subtract the 2y. So we have x minus 2y equals negative 11. On our second equation, we have the y on the left, but we don't have the x on the left. So we have to subtract the 5x over. So we have negative 5x plus 2y equals 23. This can be our system of equations that we can turn into a matrix. So what number would go instead of x? 1. So we have 1, negative 2, negative 11, negative 5, 2, 23. All right. Second matrix, edit, A. It is still a 2 by 3. 1, negative 2, negative 11, negative 5, 2, 23. Second, quit. Second matrix, math. Scroll down, option B, reduce row echelon form of second matrix. Enter, enter. Okay. So reduced row echelon form is now 1, 0, 0, 1, negative 3, 4, which means x equals negative 3, y equals 4. So our solution is the point negative 3, 4. All right. Problem C was annoying because we did all of that effort just to find out that it had no solution. And finding that out would have actually been quicker if you had used like elimination or substitution. It would have been easier and faster to see. So we have determinants. Turn the page back. All right, a determinant is a scalar, which remember that's like a number that you can multiply by. So it is a scalar found by a process called Laplace expansion, which is actually not a difficult process. It just has a difficult name because that guy discovered it, invented it, whatever. To determine if the system has a solution. a scalar found by Laplace expansion to determine if the system has a solution. The notation for finding determinant. There will either be directions, say find the determinant, or it'll be determinant of the matrix. That stands for determinant of this matrix. Or it has the matrix, but instead of having like the matrix notation, it has almost like big absolute value bars. So this also means that we want the determinant. Second order determinants. By the way, you can only find the determinant if the matrix is a square matrix. Now, matrix C was not a square matrix, but if we just looked at the coefficient piece and we didn't do the augmented part, it would be. So we can just use that like 2 by 2 section to find the determinant. So second order determinants. Here's how we find it. If we have elements A, B, C, D, what we do to get the determinant is we do A times D minus B times C. So it's kind of like cross multiplication almost, although I hate saying that because it's a weird trick that people use for everything. But it is kind of like cross multiplication. We do A times D minus B times C. All right. Be careful because subtraction is not commutative. That means you have to do A times D first and then subtract the product B times C. You can't flip them. All right, so problem A, we're finding the determinant of each matrix, which means we have A times D. So we have 0 times negative 6 minus 8 times negative 2. Or in other words, 0 times negative 6 is 0, minus 8 times negative 2 is negative 16, so 16. "16 does not mean that the answer is 16. 16 means that there is a solution. In fact, the only determinant that means there is not a solution, so it's either no solution or infinite solutions, there's not exactly one, is a determinant of 0. So if you get 0 for the determinant, don't bother solving. Unless you have to decide, is it no solution or infinite solutions? Like if you're just looking for the solution, you're not going to find a solution if your determinant is 0. Option B, or letter B. Negative 3 times 6 is what? Negative 18 minus 9 times negative 2 is also negative 18. Well, negative 18 minus negative 18 is 0. If you're not quite sure, you can put that in your calculator. Negative 18 minus negative 18. So that means our determinant is 0. So if we had a system of equations here, that we had like the augmented part, we could say that this either has no solution or infinite solutions. It does not have a solution. Okay. Really, in matrices, it means a lot more. It means that you can't find the inversion of the matrix. It's not invertible. It also means stuff for like other applications in physics and in animation and some other fields. But in terms of what we're doing, it means the system does not have a single solution. Letter C. We need to do 8 times 6 first, which is 48, minus 7 times 4, which is 28, which equals 20, not 0. So this one would have a solution. We have 10 times negative 2 is negative 20. Minus 6 times 3 is 18, which is not 0. It's negative 36. All right, to find a third order determinant, that is for a 3 by 3 matrix. So 3 by 3 matrix. This is A, B, C, D, E, F, G, H, I. This is a little bit of a weird one. Okay. You basically are splitting up the matrix into 2 by 2 matrices. So the first thing that we do is we take element A, and A is in the same row as BC, the same column as DG. So we want the 2 by 2 matrix EFHI. So we are going to find A times the determinant of EFHI. Then we're going to subtract B well, B is in the same row as A and C. It's in the same column as E and H. So we want the determinant of the matrix DFGI. So we basically want the 2 by 2 that has nothing to do with that top letter, or that top number. And our first piece is positive, positive A times the determinant, or just whatever A times the determinant, minus B times our next determinant. And then it just keeps alternating. So if we had like a 4 by 4, we would keep alternating, plus C times our last 2 by 2. When we look at element C, we can't use A, B, or Fi, so we want this matrix D, E, G, H. There will not be tons of questions about this because this is a long process. I think at this point it probably would be easier and quicker to put in the whole matrix and see if you get no solution or infinite solutions. So now we're going to find the determinant. First we have A, which is 5. So we have 5 times the determinant of what matrix? 4, 8, negative 3, 7. Minus 3 times the determinant of not this row, not this column, 6807. Plus -1 times the determinant of not this row, not this column, so 640 -3. Right, determinant AD minus BC, right? 28 minus -24. This is 28 plus 24, right? Or we could just stick this in our calculator. Let's do that. 5 times parentheses, 28 minus -24. Close your parentheses. 260. -3, and then determinant here, so we do 6 times 7 is 42, minus 0, bless you. And do you want to put the negative on the 3? Okay, if so, then we're going to be adding whatever this number is. So -3, 42 minus 0 is -126. So plus -126 or minus 126. -1. All right, determinant. 6 times -3 is -18. Minus 0 times 4 is 0. -1. -18 minus 0. And we get positive 18, so plus 18. Finally, we have 260 minus 126 plus 18 is 152. So the determinant is 152. That number matters for like higher level math, but for our purposes, it just matters that it's not 0. Like, so you have to find the number, and then you just have to say, is it 0? No, it's not. So that means that a system of equations with these coefficients would have a solution. All right. Shoot, we do not have a lot of time, do we? Okay, we're going to skip this other 3 by 3 determinant, and let's do a word problem. Austin and Emily each improved their yards by planting hostas and geraniums. They bought their supplies from the same store. Austin spent $128 on 12 hostas and 10 geraniums. Emily spent $101 on 9 hostas and 10 geraniums. What is the cost of 1 hosta and the cost of 1 geranium? So first we define our variables. X can be the cost of a hosta. Y can be the cost of geraniums. So Austin spent $128 in total. He got 12 hostas, so 12x, plus he also got 10 geraniums, so 10y. Emily spent $101. She bought 9 hostas, so 9x, and 10 geraniums, 10y. We would like to put this in a matrix because we don't want to solve it by hand, even though it wouldn't be that hard, but we want to put this in a matrix. this needs to be in ax plus by equals c form. We have the x and the y together, just the constants are on the wrong side. So we need 12x plus 10y equals 128, 9x plus 10y equals 101. And then we have our matrix. Since we're out of time, I'm just going to do this very quickly. All right, we get 1, 0, 0, 1, 9, and 2, which means since x equals 9, 1 hosta are $9 each, and geraniums are $2 each. Remember in a word problem that your answer needs to be in context. All right, I will see you on Monday.